Welcome back to another section on your finance chapter. For this video, we are going to discuss savings plans and investments. So when we talk about savings plans in this particular section, we're looking at annuities. And let me just kind of go over what that is. It's an account into which or out of which a sequence of scheduled payments is made. For example, you find your savings account. It's like a savings account, a long-term savings account, where you're putting a fixed amount away, say every month, every quarter. It's up to you how often you're putting it away. But let's just say you want to put away $100 a month. This is a formula that will show you what you would have after X amount of years of doing this. So we're going to look at an ordinary annuity, or what's called a fixed annuity. This is where equal payments are made at regular intervals. So again, you choose what those intervals are going to be. I would say typically it's going to be monthly. That's typically what most people would probably choose. And then the interest is compounded at the end of each interval. And then you have a fixed interest rate. So here is your fun looking formula. All of the variables are exactly what we've been using before. So nothing new. You still have P. Now P though, in this case, instead of it being your principal amount, like your loan amount or your savings amount, P is your payments. In other words, how much you're putting away each month. You can kind of think of it as the deposit amount. Now, I know this formula can look a little overwhelming, but I'm going to show you how we can do this by hand. But then I'm also going to show you an online calculator because I do like to incorporate technology as well. But first, I want to show you how we use that formula given, and I'm going to do it right here, given an example, and then I'll show you how we can also use this on a website using an online calculator. All right, Bill and Megan are depositing $250 each quarter into an ordinary annuity that pays 4% interest compounded quarterly. Determine the accumulated amount in the annuity after 35 years. All right, so we're going to refer back to, you can see up there, that formula, and we're going to plug in everything that we have. Right here, the 250, that's how much they're doing every quarter. That is your P for the formula. We have our R, but again, we're going to write that as a decimal. And then we have our time. We're missing one more thing. What would that be? N, how often it's compounded. Right here, compounded quarterly. So N is going to be 4 in this particular problem. All right, so we have all of our variables. Now we're going to plug it into the equation. So A equals P times, I'm going to just write it exactly how I see it in the formula, but just substituting in our variables with the numbers. 1 plus, and then it's 0.04 over 4 to the n times t. So that's going to be to the 4 times 35. Oop, there we go. Minus 1. And then all of that is over 0.04 over 4. All right, so obviously we have a lot to do. Don't get overwhelmed though, because remember what we've been talking about before, and I'll put it over here on the side. Order of operations, right? Order of operations. So we have to do parentheses first. And if you do one step at a time, I promise you it won't be as overwhelming as it might look. So I'm going to scroll up just a little bit so I have more room. When I say parentheses, okay, we do whatever's the inside parentheses first. Then we work to the outside parentheses, which is the bracket in this problem. So we're going to first work on the innermost parenthesis. That would be the 1 plus the 0.04 divided by 4. So on your calculator, take 0.04 divided by 4, then add 1 to that, okay? Let's see, that's going to give us, so do that on your calculator, and you should get 1.01. Oops, there we go. and then to the 1/40th power minus 1. Okay, that was the numerator. So all I did was we just did the parentheses that was inside the brackets. The denominator is just a fraction, so you're just going to take 0.04 divided by 4, and that's just going to give you 0.01. All right, so first step was the innermost parenthesis. Second step then is the entire parenthesis, what's inside the bracket. So on your calculator, you're going to take 1.01 to the 1/40th power, okay, enter, get your answer, and then minus 1. Okay, so take the power first, then subtract 1. So I'm going to go back down here just to get us some room here. We still have the 250, so I haven't done anything with that yet. But all we have left in here now, because we're going to take that to the exponent minus 1, and I'm just going to write down a few numbers that I'm seeing on the calculator. Try to write out as far as I can, and then divide it by 0.01. See how much nicer this looks now? Now you can do this on your calculator. You're going to take 250 times this number, then take that answer divided by 0.01. And then you're just going to round to the nearest penny. And you should get $75,677.48. So again, this problem, when you look at this formula, it does look overwhelming when you first see it. And you think, oh my goodness, I don't think I can do this. But you just take it one step at a time. Try not to skip steps and use the order of operations. So with this particular problem, you're always going to do the inner parenthesis first, then the outer parenthesis second, and then from there, you've got your multiplication followed by division. Now, I do want to show you this online calculator. So I'm going to click on this. All right. And this is a savings calculator. This is in your notes that you can find in your course. But what you can do is you can put in, for example, your savings calculator. You can put in an investment here. So if you have a starting investment, you can also look at how long do I need to save. So maybe you have a current balance. What is your savings goal? But for a savings calculator, you can start off with, let's say you're just starting off new. So we have a zero balance. Let's do this problem that we just did. We had a 4% interest rate. I don't need to turn that into a decimal because notice that it's already given it to me in that way, the interest rate. And whoops. And then how many years we're going to do this for? This is going to be for 35 years, 0 months we're just going to do, and we're making deposits of $250. And this is quarterly, okay? So it does give you the options, monthly, quarterly, half yearly, which would be semi-annual, and then yearly. All right, then how often is the interest compounded? It's quarterly, because remember, n was 4 in this problem. So it's very important to change that to whatever it is that your interest is being compounded by. Now click calculate, and let's see how close we get the answer to. Look at that exact answer. So $75,677.48. Here's what's really cool too. This is showing you how much you made or they made in this problem in interest. So over the 35 years period, they earned over $40,000 just in interest alone. Okay, so now we're going to go back to our problem, but we're going to go to a second one. This is called a sinking fund, and I'll explain why we call it that. Because this now is when you have a goal of getting a specific amount after a specific amount of time. Meaning, you don't know how much you're going to be depositing because what you know is how much you want to have. And so you're working backwards to figure out what P is. So you know what A is, but you need to figure out how much do I need to deposit in order to have this desired amount after X amount of years. Still the same problem, but same formula. But let's look at this example. Abigail and John Clayton would like to have $55,000 in 10 years to remodel their home. The Claytons decide to invest monthly in a sinking fund that pays 3.3% interest compounded monthly. How much should they invest in the sinking fund each month to accumulate $55,000 in 10 years? So notice in this problem, okay, this is not your P, this is your A. Okay, that's what they want to have. Now here's your R. So we've got the R, okay, which in this problem is going to be 0.033. And then what is our N? Let's find that over here. Here it is. It's compounded monthly. So in this particular problem, N will be 12. Okay, well now we're all set. Since we can't see the problem, or the formula, sorry, because the formula is way at the top, let me just write it down real quick. 1 plus R over N to the NT minus 1. I'm telling you, if you write this down every time, you will have this memorized before you know it. Okay, here's our formula. Now let's plug in. But we're writing it differently this time because we know A this time. We don't know P. That's what we want to figure out. All right, interest rate we said is 0.033 over 12 because it's compounded monthly. And then to the 12 times 10, because it's for 10 years, minus 1. And then to the 0.033 over 12. All right. Now, this one is going to take a little bit of work because we're going to have to do some solving. I'll show you at the end how we're going to end up simplifying. Nothing has changed, though, as far as how we're simplifying the parentheses. Same as we did before. We're going to do the innermost parenthesis first, then we'll do the outermost, but we're going to wait on that one. All right, 55,000. So we can't do anything on the left-hand side, right? But we are going to do this innermost parenthesis. So we're going to take, oops, let me keep that as a bracket, actually, because we're not done yet. So take 0.033 divided by 12, then add 1. Okay, so that's going to be your first step. I'll write down what I'm seeing here. So I'm seeing 1.00275, and that would be to the 1/20th power minus 1 all over 0.00275. You'll notice a pattern. The number in the denominator is always going to be the number to the right of the decimal, to the right of the 1. Okay, we're going to keep going. Now we did the innermost parenthesis. Now finish the bracket. Get that all down into one number. Okay, so let's see how much room I'm going to have here. We have 55,000 equals P, but now what I need to do is you're going to take the 1.00275 to the 1/20th power. Then take that answer minus 1. Then take that answer divided by the 0.00271. So that you can do. We don't have to break it down. Well, we can break it down, but we don't have to. I'll show you what I see in my calculator. And I'm just going to write down several decimal points. The further out you go, the less likely you're going to have rounding issues. All right, so that's just from taking that to the power minus 1 and then dividing by 0.00275. Notice now we have to solve for P. Ooh, so when we have to solve for P, remember you have to divide both sides by that number. That means over here on the left, this is what I'm dividing that by. All right, that should be a 4. Kind of doesn't look like it, but there we go. Now you're going to take 55,000 divided by that number. And what that's going to give us is our P. And rounding to the nearest penny as always, unless you're told to round differently, we're just going to round to the nearest penny. And what I get is $387.48. What this means is if they want $55,000 in 10 years, they're going to have to put away this amount over the next 10 years every month. Then that ends this for this particular type of annuity. In the next video, which is a continuation of this same section, but in the next video, we're going to switch to a different type of investment where we're going to look at cash investments, bonds, and stocks.